What is up, bros? Care to Math. Thanks for tuning in. We're talking today about adding, subtracting, and multiplying radicals. So this is in chapter 6 for us. We got 3 rules here, all right? First thing you want to do is you want to simplify the radicals if you can. Second thing you want to do, both radicands, all right? The expression underneath the radical need to be the same, and both indexes need to be the same. So let me paint a little picture here for you, because there's some vocab words here. They might have you afraid, scared, whatever it is. But we'll go over it so you're not afraid or scared. So this thing is called the radical, right? Now inside is the radicand, right? So that's the radicand inside. And then this little thing right here, whatever number's in there, that's the index. So we have the radicand, the index. So those are 2 things that you want to make sure you know, because that's going to help you for adding and subtracting these. So if we look at example 1, right? What I want you to think about when we're looking at these is think about like terms. If I give you 3x plus 2x, you can tell me that that's 5x. Why are we allowed to do that? Because they're like terms, right? They both have an x. But if I gave you 3x plus 2y, well, I couldn't do anything, right? I can't add these. They're not like terms. This one has an x, this one has a y. So when you're thinking about radicands, indexes, think about just adding what's alike. So let's take a look here. What is my radicand for my first example? Well, my radicand is whatever underneath the radical, which in this case is 5x. All right, both of them are 5x. This is great for us. We like that. Now let's take a look and let's see what's my index. Well, if you look inside here, anyone see a number? Is it invisible? Yeah, it's invisible. But if you were to pronounce this out loud, you'd say that this is a square root, right? The index in a square root is just 2. We just don't write it. We can just assume it. So the index for both of these is it's a square root. They're both the same, right? These are both 2's. We like that. So we can go ahead, and what we can do now is we can actually rewrite this as 3 minus 2, and we're just going to write one of these because we know in the end that's my answer, right? So I have 1 square root of 5x. We have our answer, folks, right? 5x, I can't simplify it all. So we just have 1 square root of 5x or just the square root of 5x. Let's take a look at example 2. All right. Radicand. My radicand for my first one is the square root of 7. All right. My radicand for the second one is 5. Do they equal each other? They do not. So guess what? My answer here is I'm just going to rewrite this. Right? I can't simplify the square root of 7. I can't simplify the square root of 5. So there's nothing I can do here to make these the same. They both have the same index. That's great, but I need the same radicand as well, or else I just can't add or subtract, right? So let's take a look at example 3 here. All right. Anything I can simplify, first of all. Think about that while I'm writing the word radicand. Is there anything I can simplify? 7xy, 7xy. Can't simplify anything, right? But this is looking good for us. We have 7xy equals 7xy. We like that. Those are the same. How about my index? Well, I have a 3 and I have a 5. Do they equal each other? They do not. So guess what? I'm just rewriting this as it is because this is my answer. 7xy minus 8, 5th root of 7xy. We have ourselves an answer. Example 2 and 3, pretty easy, right? We just got to check. All right, let's take a look at example 3. So right off the bat, what am I seeing? Well, first thing I'm seeing is I notice that the indexes are the same. The second thing I'm seeing is I'm seeing that the radicands are not the same, right? This is 2x to the fourth. This is 16x to the fourth. But remember, what's rule number 1? Simplify if you can. So let's just split this up into 2 different segments here. So I'm going to take on this side negative 2 cube root of 2x to the fourth. Over here, I'm going to take negative 2 cube root of 16x to the fourth. All right, and let's simplify this down a little bit, right? So remember how to simplify here. We get the cube root of 2, the cube root of x to the fourth. So let's take a look. Left side, negative 2. Can I take the cube root of 2? Can I simplify that anymore? I cannot. What about over here, though? I could take the cube root, and remember, I want to take this x to the fourth and make it into something where if I add 2 exponents, it'll get me back to 4. But one of them I want to be divisible by 3. What does that look like? Well, I'm going to do cube root of x to the third, cube root of x to the fourth, because what is x to the third times x to the first? That's just x to the fourth. So that's how I can split up my exponent. And this is great now because I have the cube root of x to the third. So I'm going to take this 3 and divide it by this 3. So I get negative 2 cube root of 2. Cube root of x to the third is just x to the first, or x. And I can't do anything to the cube root of x. Everything that's on the outside goes together. Everything that's on the inside goes together. Let's take a look over here. Negative 2 cube root of 16, cube root of x to the fourth. All right, so negative 2. Let's split up the cube root of 16, right? So what's a perfect cube that goes into 16? Think about that, right? Perfect cubes. What's 2 cubed? Well, 2 cubed is 8. Does 8 go into 16? Sure does. 8 times 2 is 16, right? So I can split that up. We already did this one over here, x to the fourth, but we can just show that again, right? I'm splitting that up into x to the third and x to the first, because if I multiply cube root of x to the third times cube root of x to the fourth, x to the first, it would get me back to x to the fourth. Now we're simplifying everything we can. Cube root of 8 is just 2. So that becomes 2. Can't do the cube root of 2. Cube root of x to the third is just x. And the cube root of x to the first is just x. Everything on the outside goes together. Everything on the inside goes together. Oh. Sorry about that. Negative 2 times negative 2 is just negative 4. And it's negative 4x, because remember I have this and this. And then I have the cube root of 2x on the inside. All right, now let's take a look. Let's pair these up together now. Maybe in red. Negative 2x cube root of 2x minus 4x cube root of 2x. All right, first things first. Radican. What is it? 2x equals 2x. Sure do. What about the index? Well, this one's 3. The other one's 3. Great. So all I got to do now is just combine these, if I can. Well, let's see. I'm going to make this negative 6. Oops. Jumped the gun. Negative 2x minus 4x. And then the cube root of 2x, right? I just need one of them. Negative 2x minus 4x is negative 6x. Cube root of 2x. And we have our answer now. So just right off the bat, if you didn't remember rule number 1, you may have just ruled this off, right? Because this 16 and this 2 didn't match up. But rule number 1, simplify if you can. So yeah, we had to do all this work over here and over here. But in the end, we got the correct answer of negative 6x cube root of 2x. Thanks for hanging on with me. I appreciate it. Go math. Hope you had some fun.